Okay, so here our topic is heat transfer and how things reach equilibrium, what that looks like on a macro and micro level. All right. I've got some hot metal and I've got some room temperature water. The water is at 22, and then the water, the metal is about 90, 100 something. I'm going to take my metal. And I slide it in, all right, to there. What's that doing there? All right, it's at 27 now. And if I raise that, there you can see it's climbing up. All right. It's going up to 30 and upwards and beyond. All right. All right. So I'm going to draw these things on a macro level and a micro level. When they're separate, when they're coming together, it's contact and thermal equilibrium. All right. I would use two colors. I couldn't find a red one. This should be red, and the hot, the cold, and then this is when they're uniform temperature. So here's what they're gonna look identical. Now these are not, the water in the example wasn't a solid, but I'm gonna draw it like a solid. You can see they're gonna look identical, and the only difference really is one's vibrating more than the other. All right. Then when they come into contact, you're gonna have collisions, and these are gonna collide with each other, and then that energy is going to dissipate or spread out through the material. So it spreads out through the water molecule. And these guys over here, these molecules over here, will lose kinetic energy. Their temperature will go down, and these will gain kinetic energy, and they will speed up. All right. Now, eventually, it's going to reach like a uniform temperature where everything is the same and everything's moving roughly at the same kinetic energy. And that is what we call thermal equilibrium, when everything is mixed in together. Now, just to really be explicit, this is like a molecular collision. So a molecular collision, I totally spelled it wrong, would look something like this. I've got those copper atoms hitting these water molecules, and energy is being transferred from the hot copper to the cool water, all right? And it always goes from your hot system to your cold system. The hot system will lose kinetic energy, its temperature will go down, and vice versa for the cold system. And when the temperature stays the same, when it's uniform throughout everything, that's when you've reached thermal equilibrium.